Hi students, good morning to one and all. Today we are discussing the topic that is nothing but finding the maximum and minimum elements by using a divide and a conquer approach. Okay, first of all, if we have to learn about what is divide and conquer technique, if you know all, there are three steps at each level of recursion. Okay, the first step is nothing but, first of all, if we have to divide the problem into number of smaller units called sub problems. First of all, if you take some array of elements, if we have to divide the problem into a sub problems, okay, that is the first step. And coming to the second step, if we have to conquer is nothing but a solve the sub problems recursively, we can say repetitively. We have to conquer the sub problems recursively. And then finally the third step is nothing but, if we have to combine the solutions of all the sub problems into a solution for the original problem. Okay, this is the process of a divide and conquer a technique. First of all, what if we have to do, if we have to divide the problem into number of smaller units called sub problems, and then if we have to conquer those sub problems recursively, and then finally if we have to combine the solutions of all the sub problems into a solution for the original problem. This is the concept of a divide and a conquer technique, how we want to divide and how you want to conquer, and finally if we have to combine the solution of all the sub problems into a solution for the original problem. Today we will discuss the topic that is nothing but finding the maximum and minimum element by using a divide and a conquer a technique. If you have to follow these four steps, it's very important to do the task of maximum and minimum element by using a divide and a conquer a method. First step is nothing but, let us consider a simple problem that can be solved by using a divide and a conquer a technique. First of all, if we have to, let us consider a simple problem that can be solved by using a divide and conquer a technique. Coming to the second point, if we have some problem, if we find the maximum and minimum values in a set of n elements, if we have to take one array, in that array the problem is to find the maximum value and the minimum value in a set of n elements. Coming to the third step, by comparing in the sense, if we have to do the comparisons, number of elements, like by comparing a number of elements, the time complexity of this particular algorithm can be analyzed. By comparing those number of elements, we have to comparing the time complexity of this algorithm, how much time it requires to occupy the time complexity of this algorithm, it can be analyzed. And coming to the fourth step, that is nothing but finally, since the time is determined, how much time, if we have to determine mainly by the total cost of the element, a comparison was the last step here. Since the time is determined mainly by the total cost of the element, a comparison. Okay, this is the concept of a maximum and a minimum element by using a divide and conquer a technique. Let us see the algorithm of that algorithm, in the sense it's like a pseudocode of maximum and minimum element of you are finding a maximum and minimum element by using a divide and a conquer a technique. Let us see the algorithm here. Let us explain here. Listen carefully. Algorithm, if we have take some name, straight, max, min, in that if we have to declare some variables like array a comma n, in the sense size of an array, comma max comma min. Max is a variable, min is also a variable. If you have to take some maximum element, and if you have to take some minimum element, some array of elements, if we have to take some, again size of an array is there. What is the meaning of that? In the sense, set max to the maximum value and min to the minimum value of array of 1 to n. Okay, and then if we have to open brace, and then if we have to assign array of 1 indices to minimum and then assign to a maximum, here we have to declare assignment. Max is assigned to, min is assigned to array of 1 indices, semicolon. And then if we have to write the for loop here, for I is equal to 2 to n do, if we have to write the for loop here, initially the I value is assigned to 2 up to n elements. Now do the task here. If you write some condition, if array of I is greater than maximum element, then if we have to check the condition, max is assigned to array of I, semicolon. Okay, and then if we have to check one more condition here, if array of I less than minimum value, then if we have to check the condition, minimum is assigned to array of I. The explanation of this content here, let us, if we have to take some straight max min, it requires 2 into n minus 1 element comparisons. Here we have to take 2 into n minus 1 element comparisons in the best and average and worst cases. If we have to follow this 2 into n minus 1 element comparisons, here we, by realizing the comparisons of array of I max is false, so we have to improvement in an algorithm, it can be done. Okay, here we are comparisons like a maximum element and a minimum element. Since we can replace the contents of the for loop, if we have to check the conditions, array of I is greater than max value, then max is assigned to array of I. Else, if one more condition, array of I is less than the minimum content of that value, 2 into n minus 1 element comparisons, so we have to study about the average array of I is greater than maximum value of half of the time. Okay, so the average number of comparisons is 3n by 2 minus 1. Okay, like this explanation of this particular algorithm. Here we have to follow a divide and conquer algorithm for this particular problem would proceed as follows. Here look at this algorithm explanation here. If we have to write this algorithm like this, max min is the name of that particular algorithm, and if we have to take some variables I comma j comma maximum element comma minimum element, let us take some comments. What is what? A of array of 1 colon n is nothing but it is a global array, and if we have to take some parameters like I and j, these are some integers of 1 less than or equal to I less than or equal to j less than or equal to n. So the effect here is initialized the numbers I is equal to some 4, I to 4, some 4 elements if we have to take here. Next, if we have to set maximum value and minimum value to the largest and smallest values of 5 in a 1 I colon j, array of I colon j respectively. If we have to take some 5 elements 0 up to 4, I is equal to 0 to 4, it's if we have say take some array of elements like that indices, if the condition, if we have to check I is assigned to j, then if we have to wrote maximum value is assigned to, minimum value is assigned to array of I. Else, if we have to check the condition, if I is assigned to a j minus 1, then if we have to check the condition array of I is less than array of j, then if we have to check the maximum element of an array is initialized to array of j semicolon, and then if we have to take a minimum is assigned to array of I, and then else the check the conditions likewise max is assigned to array of I and minimum value is assigned to array of j. Else if we have to check the condition, next if we have to move to the array of some elements like first if we have to divide the problem, mid is assigned to the first element and the last element is divided by 2. Then if we have to take some maximum element, a minimum element, if we have to assign mid value and maximum value, minimum value and initialization value also. And then if we have to take max min, mid plus 1 comma j comma max 1 comma min 1. If max less than max 1, then if we have to go to the max is assigned to max 1. If minimum value is greater than to minimum 1, then if we have to assign min is equal to minimum value number 1. Let us see the example if we have to understand in a clear cut way. Okay. Now we have to see one example of this finding the maximum and minimum element by using divide and conquer technique. Let us see this example here. This is nothing but some array of elements, array consisting of some group of elements. Let us I consider 0 to 7 elements, nothing but n is equal to 8. In the sense size of an array is equal to 8 elements. First of all I want to follow mid is assigned to I plus j by 2. I in the sense starting element and j in the sense ending element divided by 2. Starting element 0 plus ending element 7 divided by 2. Approximately we get the value 3.5. That in the sense 3 is the mid value of this array. Okay, now if we have to divide the problem into a smaller units called as sub problems. Okay, if we have to divide the left hand side, if we have to look at a 5, a 7, a 3, a 4, and then right hand side if we have to look at 9, a 12, a 6, a 2. Okay, if we have to divide in the sense if we have to conquer the sub problem recursively, in the sense if we have to solve the problem repetitively, like if we have to divide the problem into a smaller units like sub problems. If we have to divide this array into 5, 7 is one unit, and coming to the next 3, 4 is another unit, and coming to the right hand side if we have to divide the array into 9, 12 is 1 unit, and 6 and 2 is 1 unit. Okay, now if we have to check the conditions here, if array of I is greater than maximum value, if we have to check the values maximum, minimum, here if we have to look at this left hand side, here the values they are mentioned 5, 7. 7 is the maximum value, 5 is the minimum value, and look at the right side of this array. Here max 1 is equal to, here if you have to compare 3, 4, which one is greater, that is nothing but maximum value, which one is lesser, that is nothing but minimum value. Here max 1 value is equal to 4, minimum value 1 is equal to 3. Okay, and coming to the right hand side, if we have to check the comparisons, if we have to check the conditions, maximum value and minimum value, maximum value is assigned to 12 and minimum value is assigned to 9. Here coming to the right hand side, maximum 1, 6 and 2 if we have to compare, 6 is bigger, 2 is lesser. 6 in the sense maximum 1 value, 2 is minimum value of 1. Now we have to compare the conditions of left hand side and right hand side, and finally if we have to combine the solution into a original solution, here look at this, a max is assigned to, here if we have to compare maximum value 7, 4, which one is maximum, 7 is the maximum, and coming to the minimum element value 5, 3, here which one is minimum value, 3 is the minimum value, and coming to the right side if we have to check the condition of max comma max 1, 12 comma 6, which one is bigger? 12 is the maximum element of value 1, and coming to the minimum element of value 1 is 9 comma 2, which one is minimum? 2 is the minimum value of element of an array. Now if we have to combine the solution into a original solution, if we have to check the conditions and if we have to compare, okay, and if we have to check max comma max 1, here the maximum elements 7 comma 12, which one is maximum? 12 is the maximum element. And coming to the minimum element of here 3 comma 2, here minimum value is 2. Finally you get the original solution of maximum element and minimum element. Maximum element is 12 and minimum element is 2. Likewise we have to follow the algorithm and check the example conditions. Based upon that conditions and comparisons, we get the maximum value and minimum value. This is the example of finding the maximum and minimum element by using a divide and conquer technique. Now we can watch the time complexity of finding the maximum and minimum element by using divide and conquer a technique. Let us watch now here. The time complexity of T of n is assigned to 2t of n by 2 plus 2. Let us, if we have to take T of n, time complexity is equal to 2t of n by 2 plus 2. Okay, next in place of n, if we have to take n by 2, T of n by 2, that is assigned to 2t of n by 4 plus 2. Next in place of n by 2, we have to take n by 4. T of n by 4 is assigned to 2t of n by 8 plus 2. Okay, this is the formulas. These are the three formulas you choose. Let us find out the time complexity of maximum and minimum element by using a divide and conquer technique. Let us take T of n is equal to 2t of n by 2 plus 2. In place of t, first step if we have to see 2t of n by 2 plus 2, in place of t of n by 2, we wrote 2t of n by 4 plus 2 plus 2, and then if we have to multiply T of n is equal to 2 2s are 4t of n by 4 plus 2 2s are 4 plus 2, and then time complexity of n is equal to, in place of T of n by 4, we choose the formula 2t of n by 8 plus 2. If we have to substitute in place of T of n by 4, 2t of n by 8 plus 2, and then if you have to write down the time complexity of n is equal to 8t of n by 8 plus 4 2s are 8 plus 4 plus 2. Okay, likewise if we have to write this, next if we have to assume 8 is equal to 2 power k, in place of 8 we have to write down 2 power k. Okay, T of n is assigned to 2 power k, T of n by 2 power k plus, in place of 8 what if we have to write down? 2 power k plus 4, in the sense 2 power k minus 1 plus and so on plus 2. Okay, now we have to write down in place of n, that is equal to 2, in the sense T of 2 is equal to 1. If we have to follow in place of n is equal to 2, we have to substitute n by 2 power k is equal to 2 and n is equal to 2 power k plus 1. If we have to substitute T of 2 is equal to 1, comma n by 2 power k is assigned to 2 and then n is equal to 2 power k plus 1. Finally you get the time complexity of finding the maximum and minimum element by using divide and conquer technique. The time complexity is T of n is equal to 3n minus 4 by 2. How we can get? In the sense n by 2 plus n minus 2, here n plus 2n, in the sense 3n minus 2 2s are 4 divided by 2. Finally you get the time complexity T of n is equal to 3n minus 4 divided by 2. Okay, this is the maximum and minimum element we are finding by using a divide and a conquer a technique. Thank you. If you have any doubts, can you please contact me?